I have three pictures. In each picture, I give you two functions. I would like to find the area between those two functions. So for example, the first one, I have y equals to 3, y equals to ln of 2x. I want to find the area where x goes from 1 to 4. And then I have a cube root, square root, and then the third one is pretty special. I have a cosine and a sine. So this one is pretty special because from 0 to pi over 4, cosine is on top, sine is on the bottom, but from pi over 4 to pi, sine is back to the top, cosine is on the bottom. So basically for the third picture, we will have to use two different integrals. So that is a very good problem to put on the test. Okay, let's do the easiest one. Let's do the first one. So the first one, we have, which one is on top? Y equal, the straight line is on top, the curve is on the bottom, right? So the first one, basically we have to do from 1 to 4, right? From 1 to 4, and then the graph on top, so that is 3, and then minus ln 2x, and then dx. So this is the top minus the bottom. Top curve minus the bottom curve. Okay, the antiderivative of 3 is equals to what? The antiderivative of 3 is equals to 3x, right? So that is equals to 3x. And then how about the antiderivative of ln of 2x? Okay, this is why I picked this problem. So let me erase this, and then I will just like put this up because I want to save a little bit of space for myself. Okay, here is something that we will have to know. The integral of ln x dx. This is what we discussed before, x times ln x minus x. Okay, you can look this up online. The integral of ln x, just look this up online. So integral of ln x, but we have an ln of 2x. I make the 2x in there on purpose. So if that is a 2x, so this is what we have to write first. So we will have to replace all the x with 2x, then we will have a 2x times ln 2x and then minus 2x. Do we miss anything? The answer is yes. Now, do we agree that when you take the derivative of this, I know there is a product rule, right? Do we agree that when you take the derivative of ln 2x by chain rule, that produce a 2? Listen to me one more time. When you take the derivative of this to go back to the integrand, when you take the derivative, do we agree that since each term has a 2, there is a 2? At least if you just look at the ln 2x, take the derivative of that, you have 1 over 2x and then times 2, right? Because of the chain rule. So to get rid of the extra 2, we will have to put a 1/2 in front of the whole thing, because there is a 2. So that's why I picked this problem for discussion. And then minus such that x goes from 1 to 4. And then what is that equals to? That one is equals to 3 times 4, right? So 3 times 4, and then minus 1/2. And then the 2, and then I will just do the math at the same time. So 8, and then ln 8 minus 8. So that is for the 4. And then for the 1, what do you have? Minus, and then you have a 3 minus 1/2, 2 times ln 2 minus 2. And then this, you can use a calculator, that is approximately equals to 4.3754, and this is the area between the straight line and the ln of 2x. So the next one, we have a cube root and then we have a square root. Which one is on top? So this one, we have this on top, right? So the cube root is on top and then the square root is on the bottom, because you can see that on the picture. Okay, let me match the color code of the shaded region. So they use purple, then I will just use purple. So this one, the area is equals to from 0 to 1. That is what I asked for. And then we use the top curve minus the bottom curve, which is the cube root minus the square root, and then a dx. So this, you have that is a 1/3, right? So 1/3 1/3 plus 1 is 4 over 3, and then the reciprocal is 3 over 4. This is antiderivative. And then 1/2 plus 1 is 2 over 3, right? 1/2 plus 1, sorry, not 2 over 3. 3 over 2, the reciprocal is 2 over 3, and then that goes from 0 to 1. And then you plug it in. So plug in a 1, everything becomes a 1, plug in a 0, everything is gone. So plug in a 1, so you have a 3 over 4 times 1 to the 4 over 3. Let's make that look like a 4. 4 over 3. And then minus 2/3. And then you have 1, 3 over 2. This is the upper limit. And then the lower limit, everything becomes a 0. 0, 4 over 3, minus 2 over 3, 0, 3 over 2. Alright, the second square bracket is just all 0. So this is a 3 over 4 minus a 2 over 3. And then that gives you a 1 over 12. And then this is the area between what? Between the cube root and the parabola. So that is for the second graph. And then the last graph is very special, and then that problem push you to review your unit circle as well. So let's go to the third graph. So the third graph, we have a cosine and a sine, and then I want to go from 0 to pi. And then as you can see, do you see 1 and 2? For 1, cosine is on top, sine is on the bottom. So I'm going to match the color. So I'm going to do a 1 is integral from 0 to pi over 4. And then I have a cosine minus sine, right? So cosine x minus sine of x, and then I have a dx. So the integral of cosine is equals to sine, and then the minus is going to carry over, and then the integral of sine is equals to negative cosine. And then such that x goes from 0 to pi over 4. Don't count on your calculator. You are supposed to be able to do this without a calculator. So this one, you have a sine of pi over 4. Minus becomes a plus, cosine of pi over 4. You should know what that equals to without a calculator. So that is for the upper limit, and then the lower limit is minus sine of 0 minus plus cosine of 0. Do you still remember your unit circle? If you don't remember your unit circle, now is a good opportunity to review it. So at pi over 4, at the unit circle, what is the coordinate? The coordinate is root 2 over 2, comma root 2 over 2. So sine is y, cosine is x, plus root 2 over 2. And then sine of 0 is equals to 0. Cosine of 0 is equals to 1. So you will have, what do you have? You will have a root. So this, the first parenthesis, gives you just root 2, right? And then you have a root 2 minus 1. So root 2 minus 1. This is the first area. This is number 1. The area you see in the picture. Root 2 minus 1. And then how about number 2? For number 2, do you see that the position changes, the top and bottom? For number 2, so now sine is on top, and then cosine is on the bottom. Okay, so what I'm going to do next is for number 2, I am going to go from pi over 4 and then to 1. From pi over 4, oh actually not to 1, from pi over 4 to a pi, and then this time is a sine minus a cosine. So we have a sine of x minus cosine of x dx, because the top and bottom they swap. The integral of sine is equals to negative cosine. The integral of cosine is equals to sine, so you have a minus sine of x, and then from pi over 4 to pi. And then fundamental theorem, right? So minus cosine of pi minus sine of pi, so that is the upper limit. And then you subtract, this is a FTC, fundamental theorem of calculus, minus cosine pi over 4 minus sine pi over 4. Okay, what is cosine of pi? In case you don't remember your unit circle, at pi, what do we have? 180 degree. X is equals to negative 1, y is equals to 0. At pi over 4, we have a root 2 over 2, comma root 2 over 2. This is from your unit circle. So cosine of pi, that is equals to -1, so minus -1, and then sine of pi is equals to 0, so you are subtracting a 0, and then minus, so these are just -√2/2, right? And then minus √2/2. All right, so you have a 1 minus, so you have a -2√2/2, so you are having a plus, right? So 1 plus √2. So this is the area number 2. So area 1 is, you have area 1 is √2 minus 1, and then area 2 is this 1 plus √2. So this is a 1, this is a 2, and then you add them, and then what do you get at the end? The -1 plus 1 is gone, so you have a √2 plus √2, which is equals to 2√2, right? So this is the total area. The total area, 1 plus 2, the total area. And then this is approximately equals to 2.8284. If I am putting this problem on a test, I prefer to get this answer. I will just ask everybody to report the exact answer. So in this case, I will just push you to use your unit circle. You cannot just use your calculator to give me an approximation. You will have to show all your work, and you will have to report the exact answer. All right, it's a fun problem. Okay, so that is the end of this video. If you think I picked good problem, the discussion is nice, it's clear, you learn a lot, give me a thumbs up, a subscribe, and I will see you all in the next one. Signing out.